them. But sometimes some of these stories are just needed, so we have to tell the stories. So we don't have a choice. We got to tell some of the stories for the theoretical things. So the remaining chapters are more of stories, except one chapter that has to do with network management, and I will take my time on that chapter to do a lot of stuff on network management because I see that chapter very important, very very important. Not that the story we'll be telling too on the chapters that are theoretical are not important, but somehow I don't enjoy chapters that don't have labs, that are just theoretical stuff. But we just have to tell some of those stories. So, and the reason why I'm telling some of the stories is because these ones I feel they are needed. You remember I said I will be concentrating on the core topics. Any topic that is not core, I will leave you guys to read them on your own. And that's what I did. Even though I took almost all the topics in CCNA to all the topics, where anyone that I feel like is not core topic is just too theoretical and stories, I will just leave you guys to read on them. So I think I have like 2 or 3 like that in CCNA 3. Worst case scenario, I can send you materials to help your reading, but I won't come and burn my bandwidth on those ones. Some of those ones are straightforward and they are not core topics. Okay, but there is one I'm still contemplating if I will take it or not because it's a new topic. I think we have like 2 or 3 new topics in this season 3. We have cloud computing. I'll teach cloud computing, then virtualization. The part I'm not sure yet is automation. If I'm going to teach the automation, I don't know yet, but let's see what happens next week. I want to try and wrap up this class next week. So that is what I'm trying to do. So that I will take our 3 contact next week, and that will be the end of the class. So we can prepare to write exam. And please, you people can. I don't know if I've activated the assessment. I'm not sure for season 3. You can start writing your assessment too, and so that we will not have to jam pack everything together. Once when we are done, we can start writing the assessment. And I noticed some people have not. They are yet to send me the labs for season 2. They've not finished their labs for season 2. You should also try to make sure you send all your labs, and also in the season 3. The labs in season 2 and season 3. And if you know that in season 1 you wrote and you didn't do well, you can talk to me to rewrite. You have 2 attempts. I noticed 2 people, one person didn't write at all. I don't know why. I'm waiting for the person to join, then I will call the person to find out what happened. Then there's another person that wrote. The person is very, very consistent in the class. He didn't get a good score. I can't graduate you with that class. And somehow he didn't rewrite and left it and continue with his NA2. So it cannot work that way. So I will still give the person the opportunity to rewrite if the person is interested. If not, I will just leave it like that. The person cannot graduate in that class. So let's just see how far we can go today with this our story. So what I want to talk about
Please,
today is, yep.
please, I still remember recording. Oh.
Even though it's story, I will still record. I've started the recording.
Yes, so. Thank you, sir.
You're welcome. Okay, so we want to talk about one concepts. One. You remember we talked about we gave the definition of one when we started this journey. What is the definition of one? One is basically wide area network. And I remember telling you guys when we started, if you remember, maybe it's in a one note, I think it should be in one, where I gave you the definition of LAN, local area network. I gave the definition of MAN, metropolitan area network, and also gave the definition of WAN. So, what is WAN? Wide area network. I think the best definition I've ever seen out there is the one in one of the version of this is any curriculum. I can't remember which version, but I think I am that one got stuck with me, and it says connection of 2 or more LANs, that is local area networks, separated by wide geographical location. Connection of 2 or more LANs separated by wide geographical location. And I like using this example of GTB or maybe First Bank or any of these banks. Most of these banks they have Their headquarters may be in Abuja or in Lagos. So the headquarter being in Abuja, we have of a particular bank, we have branches maybe nationwide. The one that is in Abuja is a LAN. The headquarter network is a LAN, a local area network. The branches also in each of the locations where they are also local area network. But by the time they connect all these LANs together so that all the branches can reach the headquarter to carry out transaction, that is what will give us a wide area network. So wide area network basically is the connection of two or more LANs, local area networks, separated by wide geographical location. Okay, so that is just one of my best definition. But what we want to try to talk about in this class today is how do these LANs connect together? Because somehow you saw in one of the labs that I did, I drew two routers, and people will be wondering how will this router connect to themselves. You remember I got a router, maybe a router is in maybe Abuja, and then there's another router maybe in Lagos, and these two routers are going to be linked together. And we've done a LAN, we've done a lab concerning this kind of stuff. And there's a local area network here. There's another local area network here. So this is let's say ABJ, and this is let's say Lagos. So what is going to be in this place to help us link these two routers together? That is what we want to talk about, because by this topology I just do right now, this is a good example of your wide area network. Because there's a LAN in Abuja, this is a LAN in Abuja, and there's a LAN in Lagos, and we want the two LANs to connect together and talk together, and that is going to give us what we refer to as a wide area network. So how do we achieve this? There are different ways, different methods to get this thing done. One, we're going to explore the options. We are going to talk about the old ways, that's the old school, and then we are going to talk about the new school. So today we will explain the purpose of wide area network. We'll talk about how WAN operates. We'll compare traditional WAN connectivity options. So when they say traditional now, they are talking about old schools. And then we'll now talk about the modern WAN connectivity before we now go to the internet-based connectivity. So all things being equal, I should be able to finish all of this explanation. Now, if I get to a slide, I know that this is not that important. I probably will skip so that I can take my time on the ones that are very important, especially the new technology, the modern WAN connectivity, and the most used, which is the internet base. Okay. So what is the purpose of WAN? So before we talk about it, I've explained to you guys briefly the purpose, the reason, the definition of WAN. I've given you the definition of WAN. So let's check out what they have to say here. A WAN is a telecommunication network that spans over a relatively large geographical area and is required to connect beyond the boundary of the land. Look at that quick phrase there. It is required to connect beyond the boundary of the land. So this is the key here. But when you have a connection that is beyond a LAN, that is going to give you a wide area network. So that's the key there. Okay. Now, so you can see the example here. We have we have we have a look at we have a telecommuter here. Who are the people who call telecommuters? Those are people that work from home. They are telecommuter. People that work from home are called telecommuter, like this one here. And you can see a remote user here. That is a freelancer. Not really a freelancer. It can be a staff that travels all around the world, but can connect from anywhere. And you can see we have another site here called a remote site. So this is a LAN here, and this is also a LAN here. Even this remote user can connect to the network. So and this is applicable to all these banks. The fact that you are working in the bank doesn't mean that you should be in the office 24/7 if you don't need to be in the office, because you can connect from your house to the office, and it must not be from your house. Anywhere you are in the world, as long as you have access to internet, you are able to connect. So look at the things that we can get, the benefit we can get with the WAN. Of course, we know what the LAN is already. Connection of two or more computers within in an office, set of offices, within buildings or set of buildings. And we all know what the things that we can get in a LAN. You get your computers, you get your printers, you get other devices and all of that. But if we want to now link those LANs together, that is when we begin to talk about wide area network. So look at what is said here. WAN provides networking services over large geographical area. WAN are used to interconnect remote users, not just like you saw in this diagram, networks and sites. WANs are owned and managed by, look at another keyword here of key phrase here, internet service, telephone, cable, and service provider. WANs are owned and managed by internet service, telephone, cable, satellite provider. So now that you, sorry. So now that we are taking, now when I say this is just a keyword or key phrase, you need to take note of that. Because we are trying to find out, we're trying to demystify the connection between a particular network in Lagos and that same network, or the branch or the headquarter of that network, or let me say the headquarter of a network in Lagos or in Abuja. How will they connect to the branches? We need to employ the service of wide area network. And this is why I say this is key. Once that is the wide area network are owned and managed by internet service, they should have put internet service providers, telephone, that is telephone companies like Nitel, like Glow, like Etisalat. All of these guys, they have what it takes to link us LANs together. Cable, even your cable providers, I'm talking about DSTV, they have what it takes to link us together. And satellite providers, even the satellite guys also have what it takes to link us together. But this is the problem with WAN. WAN services are provided for a fee. WAN services are provided. Why does this thing move now? WAN services are provided for a fee, meaning it is not free. So if I want to link my network in say Jos to the headquarter in Abuja, I need to get the service of these guys, this one service provider, we call them one service provider. Now, I am not talking internet, please. Anytime we talk about wide area network, students' mind will always go to the internet connection. We can have wide area network without internet. The banks can decide to connect themselves together nationwide, and they are not talking about, we're not talking about internet. If not because of the there's a word I'm looking for, escape my mind. What has happened to our Nitel? Nitel used to be, or it's supposed to be, our main one service provider. But of course, we all know what happened to Nitel. So Nitel can decide to give you one service to link your headquarter to your LAN or to your LANs, and you will be paying them, and there's nothing like internet in your organization. So it's not about internet now, it's about connecting the local area networks to the headquarter, or aggregating all the local area network wherever they are located nationwide, connecting them together. So if Nitel is going to give you that service, it's not going to be free, you need to pay. One providers offer low to high bandwidth speed over a long distance. That was in those days. And I'm going to explain why I said that. Because this guy has killed or has disrupted everything. Fiber optics has disrupted everything. It's changing the equation. Fiber optics is making everything accessible and very fast and affordable for us to link lands together. Please, if you have questions as I'm moving, you are free to ask. Okay, I thought this thing don't freeze. Okay, so we're still talking about the purpose of one. Under purpose of one, we have private and public one. A private one is a connection that is dedicated to a single customer. And what are the things you get when you go for private one? You get guaranteed service level, service level. That is like we call it SLA. There will be an agreement between you and the service provider on what they will give you, what is acceptable, the latency that is acceptable, the jitter that is acceptable, and all of that. You have consistent bandwidth and you have security. These are the things you get when you talk about private wide area network. So who are the people that can give you this private one? Nitel can give you private one connection, whereby it will be like you are the only one on the link end to end. Now, when I say Nitel can give you connection, Nitel can link you up together. What I'm simply trying to say is they know what to do within their network to give you end to end connection. All you need is what we call a point of presence. I don't know if it is in this chapter. Point of presence. What is a point of presence? As long as you have Nitel in that city where you have your local area network, and you have Nitel in the city where you are trying to connect your LAN to, then you don't have a problem. So Nitel knows what to do within their network from that source to destination and just give you a connection to your router at the other hand. And for we don't know what they do within their network, and they don't know what we do on our own end also, but they know what to do on their own hand, and we also know what to do on our own hand. There was a time I went to Nitel in Jos here because one of my old students was working in Nitel back then. And then when he took me into their engine room, I saw what is called a WAN switch. That is what they use to link people nationwide. That is to Jos and to other locations. WAN switch. And the thing was like, it was as big as a 3 bedroom flat. I was like, what is this one? He said, that's a switch. And I'm not used to that kind of a switch. I'm used to our regular small switch that we'll see in the in the lab. And I have to start asking questions. So what do you people do with this and so on and so forth? So he had to explain to me that's what they used to establish connection from maybe for different customers. It's like different customers have a different connection on that particular switch. And of course, it's his own area. I don't know. I couldn't we couldn't go beyond the basics just for me to understand something. So, okay, I think one of the reasons why I got there went there that time that a company back then that they were using the Nitel's connection to link their LAN in just to the headquarters in Lagos, and so the guy was having some issue with the configuration on the router, so they called me to come and help him out. So they just put the router in one of their server room there in at the Nitel's office. So what I'm trying to say is this: night, as long as you have point of presence is like the base station in that city and the other city where you are trying to link your LANs to, then Nitel know what to do within their own network to give you end-to-end connection. And if it is empty and you want to use, as long as they have um base station, which we call point of presence in that city and the other city, you can use them. But I don't think MTN has a license to do that. They were not given license to be a carrier. I think Glo got the license to be the carrier to link two lands together. So I'm sure of Glo and Nitel. I don't know. I don't think MTN and Airtel got the license. So when you use this private one service provider, you are sure of all of these things we've just mentioned. Consistent bandwidth, you are sure of security, and you can bargain. This is
You are
acceptable.
correct. The national carrier is Nitel and Glo.
Oh, okay, okay. Thank you. So you can bargain with them on what is acceptable to you and what is not acceptable to you. But what about a public WAN connection is typically provided by an ISP or telecommunication service provider using the internet. Most of the time, once you see that word public, let your mind go to internet. Many were using the internet for that technology. That technology has to ride on top of the internet. And that is why VPN is very popular. VPN is very popular because it doesn't matter the service provider connects you to the internet. Anywhere you are in the world, you can link two LANs together as if they are directly connected through different service providers. So you can be connected to your router. I can be using Airtel here. You can be using MTN on the other side. It doesn't matter where we have in the world, we can link these two LANs together as if they are directly connected through the help of VPN. So that's why VPN is very popular, and there are different types of VPN, all kinds of VPN all around the world. Sorry. Okay. So there is a chapter dedicated to VPN, and that's the next chapter. I will be talking about VPN in the next class. And somehow, I don't know why they removed the configuration for VPN from the CCNA. It used to be in CCNA before, but they left it in CCNP. And it is still one of the things that clients ask from uh, they want clients want you to be able to set up VPN for them. So since the configuration is not there, I will just take care of the basic explanation and then leave you guys to learn the configuration on your own. Or I can send you guys the labs from CCMP, because that's what I did for one of my students in the UK that wanted to learn how to configure VPN. I just sent him packet tracer activity that has to do with VPN, even though I took it from CCMP class. Okay? Any question before I move on, please? Because I don't want to travel
You can
far,
do, you
far before
can
you
you
ask.
can do that for us too, sir.
Are you sure you'll be able to handle it?
Ah, with God's on our help and with other videos to go along with it.
Okay.
Mm.
Let's see how it goes. When you are done with all my labs, Mr. Lalikan, you've not finished all my labs. Did you hear what I said? Mr. Paul? Okay.
I said I came back from my journey.
You have plenty labs that you have not done now. In CCNA2, there are plenty labs you didn't submit.
I want to do that, sir, by
So
God's grace,
don't ask me
this
for
this week
VPN
and next
labs
week.
when you have not done the CCNA2 labs. So I will not send VPN labs to you. I can send to the others that have done their
Okay,
labs.
sir.
But you have to finish the CCNA2
Okay,
and 3 labs first.
okay, sir.
All right, so let's move on. Any other question, please? Okay, so if you don't have question, we can move on. So when you talk about wide area network, they can come in different design. It depends on what you are trying to do. So the first on the list is point-to-point topology. We have hub and spoke. We have dual home topology, full mesh, and partially mesh. So I'll just rush through this one. So let's check them out. So look at point to point here. When you say point to point, it simply means you are connecting just one site to another site, site A to site B, nothing in between. And any technology can be used to link them together. Any. Sorry, it's my pointer that is messing me up, moving this into the next page. Any. Now look at what they said here. The point-to-point connection is transparent to the customer's network. Meaning what? The customers don't even know there is something in between them. Because I have told you before, in networking, there is no distance. It's like in the spirit, there is no distance in the spirit. If you believe in witches and wizards, somebody can fly from Jos to UK now and slap somebody and come back and is back to Jos immediately. And the person in UK will feel it and know say somebody slap him. So the same thing with networking. There's no distance. Clients can see distance. We don't see that distance. So the technology just Kennedy, that's funny. But that's the truth now. I think that's a good analogy there. So somebody, you can be in your house right now. You are in Google server, you are in Yahoo server, you're on Facebook, you are traveling all around the world, even though you never left the country, because there's no distance in the spirit. So I mean, in networking, so the same thing with these connections. The users won't even know that there's something in between. Now, they are saying something here. It can be expensive if many point-to-point connections are required. Now, it depends on the technology. When we get to some of those technology, I will mention why it can be that expensive. Because if we say point-to-point, it depends sometimes on the context. Because it could be in the context of the particular technology you are using to link the two locations together. Take, for instance, now, if you are using what is called a list line, NITEC can give you a list line, and this line is very expensive. List line is very expensive. But we can also achieve the same thing using VPN. Okay, you know what, no problem. But you people should try. We can also use VPN to get the job done. So it depends on the context. So if we see, if we now want to, so if you get point-to-point connection and you want to connect multiple LANs to a particular headquarter, you are paying for each of the links. You are not just paying for one link. So if, for instance, now we move to another slide where we now have hub and spoke topology. This is what most of the banks do. They use what is called hub and spoke topology. So what is in the hub rather? The headquarter is always the hub, while the spokes are the branches. The headquarter is the hub, while the spoke are the branches. So what happens? Their server will normally be at the headquarter. So when you want to withdraw and they are doing the day-to-day banking transaction and all of that, everybody will go to the server at the headquarter for all to check all the things, maybe your balance and all of that and stuff like that. That was before the cloud came up, because right now some of them are in the cloud. They put their stuff in the cloud. So now let me go back to this explanation. Sometimes you notice if you go to bank and they tell you there is no network, but you can deposit money and they will write everything down manually. And when they have network, they will enter into it later. Well, how come there is no network? Because the server, the centralized server where they need to access to get all your details, the server is not seated with them. The server is at the headquarter. The server is where? What do you need? The server is at the headquarter. So that's why they will tell you there is no network. If anything should happen to this link now, bam, the network don't cut. But somebody will tell me, why is it that the banks cannot have backup? You know, it's difficult to have just to have a second link that you are not using and you are paying for. So if you say the bank should have the second backup, a second link as a backup, and they are not using the backup link for anything, that one is just sitting down there in case the primary links will go down. It will be costing them more money. And so they too, they want to maximize profits now. So they cannot be spending anyhow. So they will have just one connection to the headquarter. And if anything should happen to that link, maybe their service provider goes down, they will tell you when you go to withdraw, there is no network. And then you can deposit, but you cannot withdraw. But now, most of them are now, not just the banks, most companies are now moving their server into the cloud. So it's a centralized place where even the headquarters is going to the cloud, the branches are going to the cloud. As long as there is good internet connection, everybody is going to the cloud. And that is why internet is now very popular and non-negotiable to organization because of cloud computing. Because what used to be at the headquarters before, most people now moving things to the cloud. And with that, all you need is just internet connection anywhere you are, whether the branch, whether the headquarters, you can access all the resources in the cloud. So this is what is obtainable with the bank. So not just bank, organizations that have multiple branches, So the headquarters is the hub, while the branches are the spoke. Any question? Because I'm expecting a question from this one now. I have to set this thing not to be. Any question?
Yes, sir.
Please go ahead, sir.
Sir, in the cloud now, who is going to be administrator of the bank?
What do you mean by administrator? Network administrator or cloud administrator, cloud
Yes,
engineer?
network administrator that is managing the services of the bank in the cloud.
That is why we are beginning to tell people to enter the cloud right now. Because if you don't know about the cloud, they cannot hire you to do that. That's a very good question. So in the cloud, right, that's why we are saying you should think about coming to the cloud. So somebody like me now that has AWS, if they are using AWS as their cloud service provider, then I will be the engineer. If you also happen to go and do Microsoft Azure, if they are using Microsoft, then you be the engineer. You can be the engineer. But if you don't know about the clouds, how to manipulate, find your way in the cloud, manage all those resources in the cloud, it's probably going to be very difficult for you to be the one to be trusted with that responsibility. Is that clear? Is my explanation clear? Hello?
It's clear, sir.
Yes,
Okay.
yes, sir.
So you need a cloud knowledge before you can move into the cloud.
Yeah, and the engineer there will be the one to be in charge of their.
Yeah, that is why if you have CCNA and you also have cloud certification or knowledge, it's going to be a plus for you. Because right now, almost people are moving to the cloud. And when we get to the chapter that has to do with cloud computing, I'm going to explain to you guys why. By the time we are done, you will be tempted to come and join me in the cloud.
Okay.
You see, I was telling somebody, I think I was advising somebody, which I can't remember. For me, once you are done with CCNA, my advice, go this either of this direction or the two of them, cloud or cybersecurity. These two, you cannot miss the road. They are making waves like never before. Like never before. Whether you do cybersecurity or you do cloud, though, you are a big shot. But some people finish CCNA, they want to do CCMP. They want to do this. I say, what will you do with CCMP? You don't need it. Have you finished using the knowledge of CCNA on your network? Because you get to most networks, you will not do spanning tree. You are not going to do VLAN. You are not going to do interVLAN routing. You're just going to drop big basic LAN for them, default route on their router, do NAT, and connect them to the internet, and that's all. So what do you want to do with CCMP? I would say before you go to CCMP, go to the cloud first. Somebody like me now, I'm AWS certified, and I'm also an AWS instructor. I teach AWS. I'm also a cybersecurity certified, also a cybersecurity instructor. So these are just the way to go. That's always my advice for people now. Okay. Thank you. So we have another one called dual home topology. This is going to cost more money. Why do we need dual home? You remember I said, what if one of the links goes down? Now, this is just to guard against a single point of failure. Look at the design. At the headquarters here, they have just one router. The branches too, one router, and just one connection to the headquarters. We can say no, that's a single point of failure. So at the headquarters, we can have two routers. Look at the design, two routers. So one of the branches will connect to this to the two routers, one leg to this router, one leg to the other router. This other branch, so one leg to this router, one leg to the other router. The other one here, one leg to this router, one. So this is more or less like a what do you call it? creating redundancy. So if anything should happen to this link, the other link is still working. Anything should happen to this link, the other, and if anything should happen to this router, the other router is still going to be available. See, this is called a dual home topology. So this is just to guard against a single point of failure. Even though at the branch there, we still have one single router, which is also a single point of failure. But we can also replicate something like this at the branch. But you need to understand, backup is not cheap. It's always expensive. When you want to create redundant link, redundant router, redundant switch, and so on and so forth, you pay money for all of this. So that one is called dual home. And you can have full mesh. In full mesh, everybody is connected to everybody. All the branches are connected to themselves, and all the branches are connected to the headquarter. Meaning, we don't want to hear story. Everybody, there must just be a way to reach the headquarter. If I can't reach the headquarter directly, I can pass through one of the branches, and that is called full mesh. And of course, you can also have partially mesh topology, whereby you say, okay, some branches will be connected directly to themselves, to the headquarter. So either way, we have backup through some of the branches to reach the headquarter. So that one is called partially mesh topology. And so these are all the topologies you have. But the one that you see most of the time, the most common there or every time, is the hub and spoke topology. All the branches connect to the headquarter through any of the technology we are going to be talking about very soon. Any question? You see, now we've been talking stories since so, and yet we are still going to tell more story, and there is no lab. So you see why I told you guys I don't like story, 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 story. Any chapter that doesn't have lab, I don't enjoy it. But we don't have we don't get choice now. We don't have any choice. We have to tell all these stories. Any question? Can I move on? Question?
Yes, please move on, sir.
Go
Okay.
ahead, sir.
All right. Okay. So carriers connection. Another aspect of WAN design is how an organization connects to the internet. An organization usually signs a service level agreement. I talked about this earlier, SLA, with service provider. The SLA outlines the expected services relating to the reliability and availability of the connection. You give them the terms and conditions, because you are the one paying, so you need to be able to tell them what is acceptable to you and what is not acceptable. So the service provider may or may not be the actual carrier. A carrier owns and maintains physical connection and equipment between the providers and the customer. Typically, an organization will choose either a single carrier or a dual carrier one connection. A single carrier is more or less like having just one connection, while multiple is like having multiple connection. Multiple connection. So we can see an example here. We can see an example here. This corporate site is connected to just one service provider. Now, I can say ISP, Internet Service Provider. I can just call it one service provider, WSP, one service provider. So anytime I use that acronym, WSP, I'm simply referring to one service provider, not necessarily with internet connection. So you can see another connection here. This corporate site has two legs, one to ISP A and one to ISP D. ISP B. This is a dual carrier. Sorry. This is a dual carrier. So why would you want to have something like this? You want to probably load balance between the two links. You want to load balance, or you want to failover. What is the difference between the two? If you are load balancing, the two links are working simultaneously. Some people are going through this, some people are going through this link. But if you configure this network for failover, one will be active every time, the other one will be down. When the active ones go down, the one that is down comes up. That is called failover. So you can decide to have it this way. It depends on what you want to achieve. And most of the time, when why people do failover is because the second link does not have enough bandwidth. Maybe this one is maybe 10 meg, 10 Mbps, and the other one is just maybe 2 meg. So just for people not to go down completely, they switch to this, or the router automatically switch to this one when the 10 meg link goes down. Or this can be 40 and the other one is maybe 10. Okay, so they just pay small money for the secondary link so that they will not be done permanently whenever the primary link goes down. So it all depends on what you want to achieve, and it always makes sense to have different ISP when you want to go through the two. Let's say Glow here and then MTN here. Don't do like somebody an organization I know. They got Glow here and they got through another organization that is getting through Glow. You didn't get me. Let's say I started this business now as a service provider. I'm a service provider right now, and then I can give internet services. So I bought from Glow. So Glow is giving to me, and I'm giving to this organization, and this organization bought from Glow directly. You are laughing. So where is the redundancy there? Because if this Glow goes down, this one too will Glow will go down now. It doesn't make sense now. If this link becomes erratic, this one too becomes erratic. And not that they are not aware, they know that these people are buying from Glow. That is Glow that is giving them. So why are you buying from them? No, you try to give your legs connection to different service provider completely. Okay. So while would you have wide area network? It is when the organization begins to grow. That's what always, most of the time, always call for the need to have wide area network. Take for instance, when GTV first started, maybe they were just in Lagos, and from Lagos they have another branch in Abuja, and from another branch in Port Harcourt, and so on and so forth. So the more once this network begins to evolve and grow, you need to now begin to look into your design as a network administrator. Now, there's a chapter that talks about design. When we get there, I'm going to show you design for your local area network. When the local area network becomes big or bigger, what do you need to do for your wide area network? And when you have a big wide area network, as they are growing, you must have factored in all of these things in your design. Because I need to tell you, if you don't factor in the growth into your design, there will be problem in the future. You are just going to be doing cut and join with your, okay, there's another location to be added. Oh yeah, I'm not gonna just connect them to this land or connect them to the other land. It's not going to work perfectly. So in order for you to optimize the performance of your network, you must have holistic approach to your design. So that is just a summary of all of the things we are trying to talk about in this place. So you must choose the technology carefully, you must choose the protocol, and you must choose the service provider carefully to meet the demand of your organization. And what are the things you need to look into as you are choosing the technology? We're going to be talking about all of that. Okay, look at one land here. This is just an example. This is a local area network. They need access to the internet. Different ways. We can use different ways to connect them to the internet. Now, we are not used to this in Nigeria. DSL. Outside the country, they use DSL. They use cable modem and DLCell. These are different service providers that can hook you up to the internet. All they do is they drop the cable. Like for cable modem, when you talk about cable modem, the people that can give us this kind of service in Nigeria are the DSTV guys. The same cable that is giving you DSTV in your house can also give you internet connection if they want. If they want, it can also give you internet connection. Okay, so so we can connect this our LAN to the internet using DSL, using cable modem. So whether we use DSL or we use cable modem, all of these are called broadband connection because the speed they give, they are way beyond what we used to get in the days of satellites. We're going to come to that. Now, this is another design of a campus network that has been segmented into different departments, and they also need access to the internet. So what do you have in this place? You can see that we have, this is a firewall in this place here. And the firewall has three legs to each of the routers. So this is a LAN here. This is another LAN here. This is another LAN here. And this firewall is one that is connected to the internet. And the firewall is one that will bring internet connection to all of this LAN. This is another design. Now in this place right now, they are not doing VLAN. Why are they not doing VLAN? Because they don't need it. They have money to buy the routers that have multiple interfaces. They don't need it. And we can have a firewall in between to give us access to the internet. So as the network evolves, you also make sure that your design can catch up or can meet up, or the growth can meet up with the design of your network. That's why when you are designing, just a minute. Hello, sir. Yes, sir. Fine. Good evening, sir. Fine, sir. Sorry, a call was disturbing me, so I just needed to attend to the call just to so that it does not keep on cutting my connection. Can you people hear me now? Hello, can you hear me?
Yes, sir. Yes, sir.
Yes, sir.
The call was disrupting the link, so I just needed to answer the call just to so I can rest. Okay, so this is another design here. We can see the design we have in this place. So different design depending on what you want to achieve. And then I need to tell you this. This is one of the main secrets in this our field networking. Once you get your design right, you know the correct equipment to put in the correct place. You once you are done with everything, placement of those equipment, just go and sleep. But if your design is bad, you will never have rest on that network. Every day you will be wondering what's going on. What's going on? What's going on? So design is very important. It's just like architects too. Design is very, very important. I'm going to tell you guys a story. When we get to design, network design, there's a chapter on network design, and I'm not going to skip that one. I'm not going to tell you guys to read it on your own. I want to explain some things to you guys because case study was this jam guys when they first started doing online jam that people have to write jam online. That was when I got to know that design is very important. But until we get there, okay. So look at another design here. We have regional office. We have a central office. We have a remote office. We have branch office, and they all need to talk to themselves. We need to find a technology that they can use to talk to themselves. Because we have different types of wide area network technology. We have to be able to say, can we use this? If you can't use it, we'll go to the next one. We need to know which one to use. But the connectivity must be achieved. But in this case now, you can see they put internet one, meaning they are using internet to achieve this connectivity. Because that is the easiest nowadays. The cheapest, the easiest. You can get it almost anywhere to link any LAN or any branch or any remote office or any telecommuter to the central office. So how come you're going to have something like this? Because the organization is growing, the company is growing. That is why you begin to have branch office, remote office, regional office, and so on and so forth. And all of them have to be connected together. Okay, I'm going somewhere. And it's possible to have this connection all over the world. All over the world. It doesn't matter where you are in the world, we can achieve that connection. And it must not be the same technology. We can use a different technology to reach Lagos. From Lagos to maybe London, a different technology. From London to Germany, a different technology. From Germany to maybe Australia, a different. It doesn't matter. In between, as we are going on the road to the destination, we can use different wide area network technology to get the job done. They just know that it is possible to reach anywhere in the world between all your location. So sometimes organization grows to the extent that they now have thousands of employees all scattered around the world, and we need to give all of them connection. And this is an example of a distributed network whereby you have all of your staffs scattered all around the world. Okay, so these are some of the things we need to talk about on this. Talk about campus network, talk about branch network, um, small network, and so on and so forth. And let me tell you, most of the time, when you hear campus network doesn't mean university, because that's what I used to think. The first time I heard campus network, it's simply referring to a large network, where you have like 5,000 users. And it must not necessarily be a university, even though most of the time university have this crowd, they have the traffic because of students. So campus network doesn't mean university or polytechnics network. It's simply a large network, very big network where you have thousands of users. So take note of that. So any question before we move on? Any question? Addition, subtraction, objection? If you don't agree with some of the things being taught, you are free to express yourself, please. Okay, so let's move on. Is that a question?
Yes, sir. I want to ask the ISP that we are talking
Wait,
about.
wait, wait, wait. Somebody wrote something here. Wait, I'm coming. Oh, Joel. So have I clarified that now? We're in the same shoe before. He said he thought
Yes, sir.
campus network means
I
unilag.
thought when you said campus,
Nah. Campus network doesn't mean university or whatever. No, I used to think that way too before.
all right.
Yeah, good.
Okay,
Yeah.
sir.
Okay, yeah, please. Who is asking question? You should indicate before you ask so that I can give you the floor.
Okay, Luther.
Okay, please go ahead.
Sir, I want to ask that these ISP, the MTM, Glo, and other ones like Galaxy, the network they are giving, the charge is it different from the subscription that we are doing?
Yes. Do you know the difference?
No, sir.
Okay, let me give you an example now. Let's have a LAN here. Let's have a LAN because I like to be practical as much as possible for you guys so that when you enter the feed or if you're already in the feed and you don't understand some of this, I need to clarify that. Let's have a local area network. And here I have some people that want to browse. Maybe I have like 30 or 50 people. And this organization, this is their switch. Now, before they've been doing all their things before locally, they don't have problem, but they now decided to go and get internet connection. How can you give these guys internet connection? There are different ways. Way number one, I can decide to get a GSM router. Let's say this is my GSM router. It has a SIM card. Load this SIM card eh, with data, let's say 100 gig for the maybe for 1 year or 1 terabyte for 1 year. If I plug this my GSM router to this switch, it will inject internet connection to the switch. And now that this internet connection is switched, all these users will be able to browse through this GSM router that is using SIM card. And they bought 1 terabyte. Here comes Roland, the vampire, the downloader. I can download 500 gig in 1 week. Hello? Luther, are you flowing with me? The rest of you are just checking mail. You don't get problem. In 2 weeks, I am done with this 1 terabyte. The organization, the 1 terabyte has finished. Then Luther, you have to go and load another 1 terabyte. Then Roland is still on the network. He's still alive. He's not dead. He's not fired. He's growing bolder. He can finish 1 terabyte. Only me in 1 week. That is scenario one. But if you say, nope, I don't want something like this. It's not cheaper. It's not cheap for me. I want another. Sorry. I want, and this in the long run, you will spend more money because 1 terabyte maybe 100,000. I think it's around 100K or so, 150 to load one terabyte. So now in 2 weeks you have loaded 1 terabyte, 100,000. Another 2 weeks you are going to load another 100,000. You spend 200,000, and maybe by the end of the month you spend 400,000 because so every user, which is me, I'm on your network. I'm downloading anyhow because you bought data bundle. But then the organization can say, nope, they don't want to go this direction. They want to get connection from Airtel directly. So maybe they now go for something like this. They go for something, they go to talk to Airtel. We want you to give us connection. So Airtel brings their router. They connect it to their own network. So this is Airtel's network. Now Airtel will now charge you what is the speed you want to pay for? At what rate do you want to be going out and coming in? Not about the data, the amount of data you download. So you can tell Airtel, I want 2 megabit per second. So Airtel can say, you tell 2 megabit per second is 100,000 naira every month. It doesn't matter what Roland downloads on the network. Well, if Roland's like, he should bring down 1 terabyte in 1 day, 10 terabytes in 1 day, 20 terabytes, it doesn't matter. Because what you pay for this speed for 1 month, regardless of what people are downloading on your network. I don't know if it's clear to you. Hello, Luther, is it clear to you?
Yes, sir. Very, very clear. In
So
case
when
the
you buy
example of NEPA expecting data.
your, before when you were giving
Sir?
flat rate, you use boiling ring,
Yes, sir.
you use electric cooker. Now that they put
And
prepaid,
anyhow,
when they put prepaid, you behave yourself.
yes.
So those are now for some organization, they don't need this. Like I consult for one organization before. The service provider I got for them, they were paying the service provider 50K monthly. Then later on, they were having issue with the guy, so I told them to knock off the guy. So they got a GSM router, and guess what? They loaded 100,000 naira. I think it's for 1 terabyte, 100K, and the thing took them for 6 months. So they were thinking of going back to this. I said, why do you need that to do that one? Do the calculation yourself now. They are not heavy users. These are just people that go to check something from Google, just check their mail, just check the thing on some things on the network, and that's all. Now, by the time some people discover that, this network, be like say, we know they finish them on time, they started watching YouTube, moving on YouTube. So they call me. What do we do? I got them a router that can block YouTube. So on their network, you go to Facebook, you go to everywhere, but when you want to go to YouTube and Netflix, there's no way you can go to YouTube and Netflix. So I told them that that's all. If they discover people are using other sites while they are playing video, even on Facebook, people can go to video. They say I should leave Facebook for now. That's YouTube. That's the one that is popular. People use YouTube a lot on their network. So that this 100,000 naira they bought, I think it's for 1 year or so. You can check all this MTN Glo and the rest. They have all this 1 terabyte for 1 year. I think 1 terabyte for 1 year or so. If he does not carry them for 1 year, at least this 100,000 naira may end up carrying them for 8 months, which is way cheaper than go to Airtel and the rest of them. The problem with most organizations is they don't know who will help them configure their router to manage the boundary so that people can do what they are supposed to do legitimately on their network. That is where the wahala is. If all they needed is just Gmail or just to do mail and do research on Google, You block all those social medias and that will be the end. People who come to work, they will do their work. They cannot go to social media. They can't download on that network. And the data subscription will be more than enough for them. But if you know that you have vampires on your network, you better go and get Airtel directly. Any question on that, please? So is it clear, please?
Hello, sir.
Yes,
Yes,
sir.
sir.
It's clear, sir, but is this also applicable to a land that is using Wi-Fi?
Wi-Fi in what scenario?
That's like a campus area, like a campus network.
You cannot use GSM router for campus network. How much are you going to load? How much data will you load? You can't try it. As you are plugging it like this, just remove it back. They have finished the data.
Okay, sir.
No,
Because the explanation is so sweet, so I said, let me know
you can't try
so
it.
that why.
You can't try it with campus network. Lie. Just plug it. Then remove the SIM and check your balance. It's over. That 1 gig
Thank you,
that
sir.
1 terabyte you are loading, say for 1 year, one day like this, students have finished it. Even with
Thank you, sir.
you're welcome. Even with Airtel, MTN, and the rest, some organizations still do what we call bandwidth management, because the students do useless stuff on the network and they slow down the bandwidth. Like in Covenant University, when I went there to train their instructors, I got to know that they have allocated bandwidth to students monthly. So what they do is, I can't remember, maybe you are a student now and you are given 10 gig to do your assignments and check your mail for the whole month. If you like, go and watch YouTube now and burn everything down. You are not getting anything again that month until the following month. So people will now behave themselves because they have allocated data to them. Even though they have enough bandwidth, but because there's a lot of abuse on the network, because that's what students do. They burn it down, they watch movie, they don't download useless stuff that are not academically based. So they just gave them bandwidth. So if you want to go crazy, you are free. Go crazy, burn down your bandwidth. So it's any other question, please. Are we together?
Yes,
Oh,
sir.
okay. All
Yes,
right. So
sir.
can I move on? But at least you
Yes,
guys got
please.
something from this
Yes,
question.
sir.
That's why I always want you guys to ask question, because when you ask question, others will benefit from that question. Okay. So Luther, thank you for that question. It helps to also throw light into some stuffs here. Okay. Like in UJ now, I think we are going to 1 gig. 1 gig of 1 gig connection to the internet. And that's just one of our connection. I know MTN used to charge 400,000 naira for 10 meg. I don't know how much they are charging for 1 gig. Just 10 megabit per second, they charge 400,000 naira monthly. That's what I heard. You know, MTN are big, they are big shot now. They are very expensive, and also reliable. So better soup na money kill am. So if you want fast network, you must be able to pay. But if GSM router can solve the problem of small organization like 10, 20 users, 30 users, if they know how to manage the bandwidth for them, it can take care of their needs. All right, so let's go. Let's move on. Let's see how far we can go. We should be able to finish this chapter. One standard. So what is standard all about? More than one standard are defined and managed by a number of recognized authorities, include the following. All these technology we are talking about, we have standards behind those technologies. So these are the bodies that are managing this standard. We have TIA, EIA, Telecommunication Industry Association, and Electronic Industry Alliance. We have ISO, that is International Organization for Standardization, and we have IEEE, Institute of Electrical and Electronic Engineers. So these are the bodies. I think there are more than this, but I can't remember. But maybe just for one standard, that is for wide area network. These are the bodies behind this thing. Now we are going to the areas where I will spend more time again. Now look at this now. One, in the OSI model, you can't leave OSI behind though. And even if you are going towards CCI, you will still meet OSI. We will still be talking about OSI. Most one standard focus on the physical layer and data link layer. Now, if you remember, I've once mentioned this in the class. Some will tell you that wide area network technology operates only at layer 1 and layer 2. What happened at layer 3, 4, 5, 6, 7? It doesn't mean that those technologies don't go all the way to layer 7, but the layers where you can differentiate between one technology and another one technology is only at layer 1 and 2, especially layer 2. So for instance, now if I'm using DSL technology to hook up to the internet and you are using cable, once our message get to the layer 3, nobody knows you are using DSL or knows you are using cable. Nobody knows. If you are using Metro Ethernet and I'm using MPLS, nobody knows. But from layer 2, if we should capture that packet, that data at layer 2, we will know that this guy is using DSL, this guy is using cable modem, this guy is using Metro Ethernet, this one is using MPLS. That is where you will explicitly see the technology that is in use to hook up to wide area network or to connect to the internet. So that's the reason why they tell you that this wide area network technology operates at layer 1 and at layer 2. Not that other layers are not involved, but just you cannot see the difference once it gets to layer 3 and above. Okay, take note of that. So these are different technologies they just mentioned here. DSL is one. I just mentioned DSL. Cable is one. Metro Ethernet is one. MPLS is one. PPP is one. ADLT is one. Frame relay is one. ATM is one. Now look at what they wrote here. Baba, old school. Baba, old school. These are legacy. When I did my CCIE, this was given to me in my CCIE exam. Frame relay. Sorry, guys. Frame relay was given to me in my exam. This is frame relay. And now frame relay is dead. ATM is dead. These are really wide area network technology back in those days. I'm talking of 10 years ago. 10 years ago, yeah. It was in 2012 that I did my CCI. I went to India for CCI. 10 years ago. These are old technology. They are not in use again. Now look at this one too. ADLC is dying. That's why they say less use. PPP is dying. That's why they say less used. MPLS is still in use, but the guy is going the way of these people gradually. These are the guys at the top. Metro Ethernet. Wireless. I didn't see that one. Wireless. Metro Ethernet. Now, when we say wireless, there are different types of technology to connect to wireless. To set up a wireless network, we are going to probably see them in this slide also. So, in those days, we used to teach our students frame relay and how to configure frame relay, how to configure AGLC, how to configure PPP. But because they are no longer in use, so we no longer mention them in the curriculum again. We just mention them in passing. And even we don't configure ATM in those days, we just mention this one. Okay. Now, there are terminologies you need to be aware of whenever you are talking about wide area network technology. One of these is DTE. What is DTE? Data terminal equipment. These are the equipment that connect the LAN to the service provider. That is basically the equipment that belongs to the customer. This is your DTE. Like your router is a DTE device, data terminal equipment. And also we have what we call a DCE, devices used to communicate with the provider. This is an example of a DCE here. This is our modem. Our modem is a DCE. So most of the time, DCE is pointing to the service provider, while the DTE points to the user. And sometimes we now say CPE, customer premises equipment. Which one is customer premises equipment? That is the combination of our DTE and DCE and the connection in between. See the boundary here that connects us before we connect to whoever is giving us connection. So you need to be aware of this technology. This is the terminology I mentioned earlier, point of presence. Point of presence is more or less like the branch of your service provider in the city where you are. Take for instance, there was a time when Airtel was not in Jos, Glo was not in Jos. Why? They don't have point of presence in Jos. So you can't even see their signal. But the moment they drop their base station in Jos, and from the base station, they now begin to mount masts all over, and all the masts connect to base station, that means now we have their point of presence in Jos. So any service provider you want to use must have a point of presence in that city. So if the point of presence is not in that city, then you cannot use that technology, no matter how good the technology is. Take for instance, you go to your village right now and you have a land in your village, you want to hook up to another land somewhere. And Natel is not in your village, Airtel is not there, MTN is not there, all of them are not there, Fiber is not there. That's why you see people resort to satellite. They use dish. But that one is just to use dish and point to the dish satellite dish and point to satellite in the space to give to connect to another local area network somewhere. Because that one, the sky is everywhere. You can point to the sky, get the connection to the satellite, whoever is connecting you, and you are able to link the two lands together using a satellite connection. So that one is also there. So there must always be point of presence in your city for you to use the service of any service provider. Then we have another terminology called demarcation line, demarcation point, and that is where the responsibility of the service provider ends. If you say, I am not connecting, you know what they will do? They will just test from their own end all the way to the demarc. You see, demarcation point. Once they can pick the demarc from their own hand, they will tell you the remaining problem is yours. It's not their problem. Sorry, this my pen is stressing me sometimes. It stresses me sometimes. So once they are able to pick from their own hand to this place, they will just tell you, we have tested this thing up to the demarc and everything is okay. It's now left for you to know what you do for you to be able to hit the demarc too. And as long as you can hit the demarc, you should be able to go to your other destination, wherever you want to go to. So the service provider has their own responsibility, and you also have your own responsibility. So these are some of the terminology you need to be aware of. Okay, we also have what is called last mile. That is their cable that comes to your hand. Like normally use Nitel. Like in those days when they want to connect you to their network, they must run cable to your house. So it doesn't matter how far your house is to the Nitel's office, the cable must reach your house, and that is called local loop or last mile. This is our last mile here now. Yeah? Last mile comes from their own office to your own hand. Okay, then you have the central office. That is like the main office of the service provider. Take for instance all these telecom companies now, they have their main office. So if the main office is in Abuja, all the base station will report to Abuja. All the base stations nationwide are connected to Abuja. So all is more or less like a centralized place where you have all the base station. Now they can also have two network. Two network are more or less like backbone in between different regions, different environments where they can connect, they can continue their what do you call their connection. Let's say now they've gotten to Jos, they want to reach Gombe, from Gombe to Maiduguri, and they see that the distance is becoming too much. They can have a mini central office where they're going to have almost all the equipment that they have at the headquarters. And that is why sometimes this terminology, the definition between this terminology, let me say there's a thin line between the tool network, the backhaul network, and the backbone network. So we just need to be able to differentiate between them. So let me read through. Look at what they said about the toll network. It includes backhaul, you see, long haul, all digital communication fiber lines, switches, routers, and other equipment inside the one service provider network. And please, you need to know this. They use switches too. They use routers too, and other equipment. Now, what about backhaul network? It connects multiple access nodes of the service provider networks together. Like you want to connect maybe one region to another region. We don't work with them, so we don't know much about what they do. We connect multiple access nodes of the service provider network. And what about backbone network? Large, high capacity networks used to interconnect service providers network and to create a redundant network. So they have two network, they have backhaul network, and they are going to also have backbone network. That is the service provider. Now, why is it that easy? It's a lot easier for them to hire a CCNA person is because they know you know about routers, you know about switches, you know about all of these stuff. It's just for them to train you and blend your knowledge to what they do on their own network. And before you know it, you are there. Case in point, when you buy your SIM card, it's not just for you to make call. You also browse. And so the moment you on your data, you get IP address. So some people who are working with MTN that are working on the router that is connected to one of their access point. So when you have your phone somewhere and then using GSM to talk to this access point, GSM technology, this router is giving you IP address. And when you on your data, based on what is being configured, if you bought 10 gig, 5 gig, or whatever, you begin to use this router to go to the highest speed, which is the MTN or Airtel, whoever is your service provider. They also connect to other service provider and so on and so forth. Then other things we have on the network to talk about, we have the modem. We have the voice modem, which is old school. This is telephone line. It uses telephone line. But we have the modern one, which is DSL modem or cable modem. So what is the job of this modem? It's just a device to convert digital from, most some of these service provider, they talk in analog. Their traffic is analog, and on our network we talk in digital. So some of these their devices is to help us convert from analog to digital and digital back to analog. So if I'm a router, I'm connected to a modem, I'm talking digital, and this guy doesn't understand digital, or let me say the network is connected to talks in analog. So it's this guy that will interpret the digital to the analog. By the time it gets to the destination, so this other one will return it back from analog to digital so that the other router can get to know about uh, the details of the discussion. So that is the reason for this DSM modem or cable modem. DSL or cable modem. We also have CSU/DSU. That is another form of modem, but this one convert from one form of digital signal to another form of digital signal. And this is the best way for me to explain this. I'm a Yoruba man. I speak Yoruba, but do you know that if I go to Ijebu right now, the Ijebu people speak Yoruba too, but I won't be able to understand the Yoruba they are speaking. I will need an interpreter, and it's still a Yoruba language. I believe the Igbos have something like that too, whereby it's the same Igbo language but another form. So sometimes we have a technology that is digital, but it's not our own form of digital. So sometimes that kind of technology, we need CSU/DSU to convert from what they are saying to what we understand. So these are some of the equipment that you can come across on when we're talking about in the context of wide area network. And we also have optical converter. It converts fiber optic media to copper wire. Sometimes you have a switch that has a fiber port, but you don't have your connection is not fiber based, maybe it's just copper. So you can have a converter that will convert from that fiber port so that you can plug your regular UTP or STP cable on that switch or even a router. So it's just a converter. We have wireless router and access point. We've talked about this since before. And we have one core devices, which are our layer 3 switches or high speed routers. So these are some of the terminologies you will need to get to know about. Now, I see what they did in this place. They bundle so many things that we need to teach in the whole curriculum together in like 2 slides. This is like a chapter in those days. Now, I'm not going to waste time on this one. Serial communication. Why am I not going to waste time on this one? Because the technology is going away or is dead. So why are we talking about serial communication? Now, if I have a router here and I have another router here and I'm using serial port. Now, serial port, if you have, I don't know if you guys have seen it before. I will try and show you guys when I'm done with the class. It's a port on the router that you can use a serial cable to connect the router end to end, or that is in the lab, even when you are connecting one location to another location. But as long as the technology you are using uses serial port, your communication between the two routers is going to be serial communication. And so what is a serial communication all about? The communication between the two routers will be 1 bit at a time. 1 bit at a time. 1 bit at a time. So sometimes we have serial communication and sometimes we have parallel communication. Parallel communication is 8 bit at a time. Now, why did I say this is no longer relevant? Because the technology that uses this thing, they are dead. E.g., frame relay is one of the whole technology. Frame relay is one of the old technology that uses serial port. ATM also uses serial. PPP also uses serial. ADLC also uses serial. So most of these technology that we just mentioned now, they are dead. But what of the technology we talk about nowadays? All these cable modem, DSL, all of them, they use regular Ethernet ports. That is why you see me when I'm connecting two routers together nowadays. I just run the cable directly between my gigabit 00 maybe to another gigabit 00. Those are our Ethernet port as against what we used to have in those days. So let's not waste bandwidth on serial communication. Just know that it transmits bits, one bit at a time, sequentially over a single channel. Circuit switch communication. There are some of the whole technology they are referred to as circuit switch. Some are referred to as packet switch. So what is the difference between the two? Any technology that is referred to as circuit switch technology, it simply means there must be an end-to-end connection before you can transmit data. Case in point, if I call your line right now, because your phone is ringing does not mean that I will start talking. You must pick that call. And the moment you pick that call, guess what happened? There is a circuit that is established between the two of us. End-to-end connection. Excuse me. End-to-end connection. And that is why most of the things that the telecom people do, they are circuit-based. So I can only talk to you when a circuit has been established end-to-end between the two of us. So when you see some of this wide area network technology, once they tell you that it's circuit based, it simply means it's using a telephone technology whereby there must be end-to-end connection before we can transmit data. For instance, ISDN is one of the circuit-based technology. PSTN is circuit-based technology. Whereas there are other technology that are called packet switch. Packet switch. For instance, Metro Ethernet is packet switch. MPLS is packet switch. Frame relay is packet switch. ATM is packet switch. So what is packet switch? If I want to send a message to you, I can call your line and tell you the message. And at the same time, I can write a letter and go to post office and post the letter. And I know one day, that message will get to you. That is the example of packet switch. There is no need for hand-to-hand connection before the message can arrive at destination. So whenever the postmaster they will carry the message from Josh, maybe to Abuja. When they get to Abuja, they can spend another 1 month. I'm coming if I spend another 1 month to do sorting. When they are done sorting and they are God answer your prayers, they will move to maybe Lagos. When they get to Lagos, they can stay another 1 month before they sort again and start. Maybe I'm sending from just to Lagos. But either way, the message will get to destination. So there are some, and that does not mean that there is going to be a delay like that. I'm just using that one as an example. So where we have some of this wide area network technology, there is no need for end-to-end circuit connection or end-to-end connection before they can work. The way they operate is about the direct connection, then next direct connection, then next direct connection, then next direct connection, then next direct connection, and so on and so forth. Yes, Ifan, you have the floor.
Good evening, sir.
Good evening. You're welcome. You came late?
No, I've been with you, sir.
Okay. Please go ahead.
Okay, thank you, sir. You made mention of sec. I came across a third part of switching. I don't know if you can elaborate on it. I saw it in circuit switch, which is a virtual switch.
I'm not getting you.
Virtual switching. A networking material, and I come across packet switch, circuit switch, and virtual.
Yeah, packet switching. When we talk about packet switch communication, we're talking about just like what I've just explained now. when we talk about circuit switching communication or switching, we are talking about technology that switches or using this technology to work. But for the virtual, I've never heard about the virtual switching. So
All
whether
right.
we're to say packet switching or circuit switching, we're still saying the same thing. But the virtual, I've never heard about that one.
Okay, sir.
Yeah. And I don't think it's a recent thing, because if it is recent, I should have heard about it. But you can just research it on Google. Any other question, please? Okay. So we're still talking about one. The whole chapter is about wide area network. I will soon land this plane. I want to get there. Some area I will really want to emphasize on, and my time is fast running. I have to move fast now. So we have some other things to talk about briefly: SDH, SONET, and DWDM. Service provider network use fiber optics infrastructure to carry transport user data between destinations. That is the main thing nowadays, especially in the developed country. They see this as a major infrastructure, and that's the truth. We also we are supposed to see this as a major infrastructure, because we need access to the internet and at affordable rate and with good speed. And one of the best way to achieve that is for fiber to be everywhere nationwide. Unfortunately, our own government don't see this as a necessity. Even India, that is third world, that used to be third world country, let me put it that way. But when I got there, for me, I feel like we're not different when it comes to the way most of them look. You know, what you see in TV is different from what I saw there. You know, in TV you see the elite, the good-looking ones, the ones that are looking chubby, and no, it wasn't like that. But there are some things you can't take away from them. When it comes to internet connection, it's readily available almost everywhere. At that place I went to. Back then, the house I lived in, the guy he told me he pays um equivalence. When I converted to Nigeria naira, it was around 12,000 naira back then for unlimited speed. Here you still pay MTN 10 meg for 400,000 and all of that. Unlimited equivalence of 12,000. Why? Because they have the fiber connection everywhere. I mean, the government put fiber connection everywhere. Even if you don't need internet, once you make up your mind, there is fiber that will pass through in front of your house. They will just start from there and give you connection. Okay, so they have a different standard they use, which are fiber related issue. I'm not going to go into the details of those ones, because I don't know much about this fiber stuff. So they call one SDH, synchronous digital hierarchy, and they call another one SONET, synchronous optical network. The SDH is a global standard for transporting data over fiber optic cable. Now, after this class, if you don't know much about fiber, you want to learn more about fiber, not as in how to terminate fiber, all of that, you can just check I forgot what they call it. You know, there is a fiber connection from London to Nigeria that passed through the ocean. You can check it out on Google. You see the way they lay fiber in the ocean to pass through from Europe to Africa. So the standard for SONET, that is the North American standard that provides the same speed. So whether SDH or SONET, it defines how to transfer multiple data, voice, and video communication over fiber. Of course, you know fiber uses laser and LED over great distance. So these are just standard. And also we have DWDM, dense wavelength division multiplexing. It's a newer technology that increases the data capacity of SDH and SONET by simultaneously sending multiple streams of data, multiplexing, using different wavelength of light. No, they are also innovating and expanding on how to make the speed, need to improve the speed of fiber and then the reliability of fiber. So these are just standards that operate on fiber optics. So let's go to the traditional one, connectivity. I'm going to rush through these ones. Okay, I've told you these are the old school. So we used to have what is called dedicated, and the dedicated is the least line. And why is it called dedicated? Once they give you, you have been given. It cannot be shared. And the example of this line is T1, E1, T3/E3. We used to teach that in those days in CCNA. And then we have the example of switch. And under switch, we have sweep, circuit switch, and packet switch. An example of this is PSTN and ISDN. These are called circuit switch, and I've explained to you why they are called circuit switch. And of course, frame relay and ATM, and I've explained to you why they are called packet switch. So these are old school technology. So people use all of these to get connectivity in those days, but they have died, and now people are moving to the newer technology. And one of the reasons why they have to go is because, let me give you an example. One of the reasons why they have to go, let me give you an example. Sorry. Like this guy here, frame relay, the maximum speed frame relay can give you is 45 Mbps on one link. And people are talking of 1 gig. So you can no longer, you can't meet up. Even ATM that time, the maximum speed ATM can give is 155 Mbps. Mbps. So you can no longer fit into today's technology. So we have to leave those technology behind and move on. In their days, they were raining, but now we've switched to other technology. So that's just the summary. And for T1, this is the speed of T1, and this is the speed of T3. This is the speed of E1, and this is the maximum speed of E3. Look at what E3 can give us, 34 meg, and we are talking of 100 meg, 200 meg, 300 meg, 500 meg, and so on and so forth. So these guys have died. So they have, back then they have their advantages and disadvantages. So what's in the advantages is, you can see them here: simplicity, the quality is assured, and of course they are readily available. Disadvantages: crazily expensive, cost, and limited flexibility. For lease line in particular, lease line it's expensive, and it's not flexible. You can't share the link. There are other technology that are available back then that are kind of flexible, like frame relay. Frame relay, you can share the link of frame relay between service provider, between customers. But because they are old technology, we are not going to go into all of that. Of course, circuit switch, I've explained why they call it circuit switch. And then ISN and PSTN are the two types that you can mention majorly. They are under circuit switch. I've explained frame relay, and I've also explained basically what it does. So I don't want to go into all of those ones because they are no longer in vogue. This is where we are going nowadays. These are the modern one technology. I told you about DSL, I told you about cable modem, and of course fiber. And that is what we are using nowadays. So nowadays people use fiber connection, and that is why you see almost everybody, people are laying fiber everywhere. And some companies, when they lay fiber, you don't need to have your own fiber connection. You can rent from them. Let's say now you are in Abuja, you have a land in ABJ, and you have another land in maybe Port Harcourt, and you want to link the two lands together. As long as that company has that fiber connection in Abuja and they have the fiber connection in Port Harcourt, you can rent the connection from them, and they can give you end-to-end connection all the way from Abuja to Port Harcourt, and you pay them monthly for using their link, or yearly for using their link. So some are now building that. Since our government will not do it, some are now doing it, so they make money from it. If the government has done that, that becomes another means of generating revenue for the country, because anybody that want to use it, either to connect to the internet or to link your lands together, you pay to use the fiber connection. So these are the new ones we have, and there are different way of implementing this. We can see what we have here. Under our dedicated, we have broadband and we have dark fiber. That is mainly fiber. Of course, we still have our switch, not the circuit switch, packet switch. Under packet switch, we have two technology there. We have Ethernet 1. That is more or less like extended. Oh, wow, this pen is just messing up my slide though. That's more or less like extending your LAN. That is the technology on your LAN to wide area network. And of course, we also have MPLS. People still use MPLS nowadays. So these are different things that can be used to link up LANs to LANs, or to link us to the internet. But majorly for internet base, which is broadband VPN, we have wired, which is, it can be DSL, it can be cable, it can be through fiber, and the wireless can be through regular Wi-Fi that you know. It can be through cellular, It can be through satellite, and it can be through the latest Wi-Fi technology called WiMAX. That is another fantastic wireless technology that can cover crazy distance with crazy speed. WiMAX. So either way, we can get connected to the internet with all of this technology, wired or wireless. So we can see them here. Under Ethernet 1, there are different varieties of them. So service provider now offers Ethernet 1 service using fiber optic cable. The Ethernet 1 service can go by many names. Number 1, Metropolitan Ethernet, Ethernet over MPLS, or Virtual Private LAN service. So what would be the difference between this technology? Is in the equipment that is in between. Oh, sorry. It's the equipment that will be in between and the behavior of the equipment. And when I say behavior, I mean maybe the speed, the way it transfer data, and so on and so forth. The details are not covered in CCNA. That is what we differentiate the technology from one another. I know this one is very popular nowadays with banks. They use virtual private LAN service and so on and so forth. And there are several benefits to an Ethernet 1. It reduces expenses and administration, easy integration with existing network. Can you imagine you extending your network from Jos to Abuja? You have VLAN in Jos here, and that VLAN can continue in Abuja. And ideally, Abuja is supposed to have a different set of networks entirely. That is the way they implement Ethernet 1. Enhance business productivity. It can enhance business productivity. So look at what they said here. Ethernet 1 have gained in popularity and now commonly being in use to replace the serial point-to-point, that is our lease line, the frame relay, and HM1 link. So these are technology we just need to be aware of, but we don't do any configuration on our own hand on this technology. Now I've mentioned MPLS is another fantastic technology out there for connectivity. The summary of MPLS is it converts your layer 3 information to a layer 2. I also did MPLS. It's not something we can talk on in one slide, but somehow the technology implementation is very simple and straightforward. So basically, it converts your layer 3 information to layer 2, and with that, it's able to make what is called label. And because of that, the transmission of data end to end is faster because decision is not made at layer 3 with MPLS technology. Decision for routing is not made at layer 2 for MPLS. And of course, our remaining technology, which are the one we mentioned earlier, DSL or cable or optical fiber. It's all the equipment that differentiate between the technology. So if I say DSL now, it means the service provider has one equipment on its own hand, and they have decided to call that technology DSL technology. If I say cable now, they have cable on their own hand, and they have decided to call it cable modem technology. So we call it cable modem technology. So what do we need to learn about the technology? What is the speed? What is the distance? What is the reliability of that technology? Because they don't all have the same speed, or they don't all have the same distance coverage, and they don't all have the same reliability. There is one of them, I don't know if it is here. The further you go, or the more users you have on the network, it will be reduced, the lower the speed of that your network. Let me read this one and see if it's the one. See that DSL or cable modem. Digital subscriber line is a high-speed, always-on connection technology that uses existing twisted pair telephone lines to provide IP services to users. Okay, this is what I'm actually looking for. The DSL transfer rate are dependent on the actual length of the local loop. So if your house is far away from the service provider, your speed is going to be reduced. You're not going to have good speed. And the type and the condition of the cabling. So look at what I'm saying here right now. Take for instance now, this guy here want to connect to the internet. And this is the service provider here, which is equipment. He gave you a modem. This modem can be dropped in your house. So this is what determines how fast your network is going to be, the distance to your house. If it's too far, there will be a challenge with your speed. So when they have their own point of presence, there is a distance they can cover. And once you are beyond that distance, they can't reach you. And look at what they said there. This is what I'm looking for. It's not a shared medium. It does not matter the numbers of users on that network. You're not sharing the bandwidth. Whereas there's another one that is shared. I believe that is cable modem. So each user has a direct connection to the DSLAM. What is the DSLAM? That is the equipment at the service providers, and that is giving you that access to the internet. Hiding user does not impede performance. This is their main equipment here. But let's go to, so there's a configuration on that, not in packet tracer. You can design it there's a lab on that. So I won't want to go into this configuration because it's not designed in packet tracer. But if you are interested in designing it, I will download the PDF and send to you. So this is another one. What differentiates this one from the other one? Look at their own equipment. Look at what is in between. Look at their own cable modem. But this one, I believe, is a shared technology. Let me look for it. Look at it. All the local subscribers share the same cable bandwidth. As more users join the service, available bandwidth may drop below the expected rate. So if you now want to make up your mind to go for cable modem, DSL or cable, you need to know the behavior of the two. And sometimes it's not you don't have the choice. Which one is available around your way and your environment? If it is not available, there is nothing you can do about it. If you have options, the DSL is there, cable modem is there, you are the one to now make up your mind as to say this is the one I want to go for. And of course, we have optical fiber. Optical fiber can deliver anything you want, any speed you want, as long as you have the money, you have the speed. It doesn't matter what you want, the speed you want. The bandwidth of fiber is not threatened. And of course, if you go to wireless, there are different means for wireless connection. We have the regular wireless. When you see municipal wireless, you're talking about multiple access points that will overlap so that you can cover a city and you have the speed. And of course, you people know about cellular, and that's why you talk about 4G, and then you talk about 5G, and this is the one we're waiting for now because it's going to make your life better. If you have 5G and you have GSM router, drop in an organization. If not because of the way, what do you call it, data is expensive in Nigeria, most of this organization will have been going for this GSM router. Just load, let's imagine you load 1,000 naira and they give you 100 1 terabyte for 1 month. Why do you need to connect to MTN and get direct connection or Airtel? You don't need that. And the truth is, in developed countries, they have this thing is affordable, readily affordable, and very, very cheap. So maybe when you get to 5G, probably the price will drop. And of course, you can connect through the satellite internet. This is the latest wireless technology. The distance you can cover is crazy. And you can imagine MTN dropping where they're supposed to drop 10 masts, they just drop 2 masts and the whole city is covered. That is with the help of WiMAX. WiMAX technology is very, very is solid, is the distance is crazy and the speed is also crazy. But not many service providers have this for now. Maybe with time they will have all of these things. Okay, so the last part is VPN technology. We have a chapter dedicated to VPN. I don't think we should waste time on this. So what is VPN? We can create tunnel through the internet as if we are the only one on the internet to link two lands together. So I can be here, I'm in Jos, you are somewhere, maybe in Port Harcourt. As long as you're on the internet, you are on the internet, I am on the internet, we can create tunnel between the two routers as if we are the only one on the internet so that these two people can talk to themselves. So what is the benefit of this? It's very cheap, it's very secure, it's scalable, I can wake up tomorrow now, another person in another location will join the person to our network. Another person in another will join the person to our network. So it can grow. And compatibility with broadband technology. It does not matter what you use to connect to the internet. We don't care. Just get internet access. We can link you up. So VPN has really changed the dynamics of connection around the world, and it's very secure. So we have a chapter dedicated to VPN. That's the next chapter we're going to do in the next class. So when you connect to the service provider, different ways to connect. You can have just one connection. That is called single home. You can have two connections to the same service provider. Maybe one link is down, the other one is still up. That is dual home. And you can have two legs to different service provider. That is called multi-home. And you can have two legs to different service provider, and that is called dual multi-home. So you need to be aware of all of these things. So this is a comparison between all of this technology. You should be able to do the comparison yourself. You need to know which one is expensive, what is the speed you are being given, and what is the distance you can cover. So you know, you go for a particular solution when you see the availability first, then you talk about the money, the speed, then the money, or the money first before the speed, depending on whichever one. So you should be able to compare and contrast which one can serve you best. Like the organization I mentioned, that they are using GSM router now and it's serving them. They are very happy. They are going to maybe 1 year now, no problem, and just 100,000 naira for more than, is it 8 months right now? I think it took, the first one took them 6 months. They loaded again, and they are going to maybe another 4 months now, which is very good for. So you weigh your options and see the one that is very okay for you. All right, that takes us to the end of the journey on one wide area network. Any question? Any question? Am I alone? You people are still with me. Hello?
Yeah, with you, sir.
Okay. Do we have question?